Alright, so it looks like we are good to go. Let me turn this down a little bit. Hello everyone and welcome back to Data Vault. It's been a hot second since we've done some of this stuff. I'm just going to, I know people want WebAssembly stuff, but I'm just going to try and wrap up this series a little bit. I did quite a bit of work on debugging the other functions and making sure that they all worked, and I think I found a way to make them work. However, I'm not going to make videos on them because I think that if you watch the videos on creating the data and the other sequences and actually writing the code for that, you would see, man, this really isn't that fun to watch, because it's just a lot of convoluted logic and it's just spaghetti code. But there wasn't really too much value to it. However, this video will be focused on actually creating a user interface, so a way that the user can interact with our system without having to write their code or the code themselves. So if we look at this right now, this is just the main file, and I created a bit of a test suite. I guess this is kind of valuable, but essentially this just calls a function and we get the return code, and then we will say, all right, log the return code based on what we expect. So if it's a success, then we want to say pass, and we can increment a number here, so on and so forth. However, the user would still have to write this code, and I don't know if they would want to, because there is quite a bit of memory management involved. They have to write out all this logic, and we don't really want them to have to recompile the application every time they want to run it. We just want them to say, hey, I want to open up this application, I want to log in, I want to do this, and I want to create data, I want to access my data, I want to edit my data, this, and then log out. We don't want them to have to write those instructions and compile them every time and have to look at, oh, why is this not working? We just want them to say run, or however we'll say it for now through the terminal is just run, and then they will log in with the command, do everything with the command through the terminal, and then they will log out with the command. But we don't want to have them look at any of this overhead of kill the app, initialize the app, create the account. We don't want them to look at any of this stuff. Nobody is going to know what a const character pointer is. We just want them to enter it. So what we're going to do is we're going to create an interface. So we're going to go into our source file. We have the controller folder, and then we're going to create a view folder. So new folder, view. And then we also have terminal. Nope, that's a file and it should be a folder. So we're going to create a folder for the terminal view. New folder, terminal. So right now, if we were to run it, so I'm just going to go into PowerShell and show you guys this. So in Data Vault, so I'm in the directory, go into test, and if a user were to run this right now, and they would have to recompile it, they'd have to do /run, and they would see this massive command that they probably don't know what it looks like, and it looks like I'm getting a couple failing tests. But this is kind of what the test suite looks like. It's just description of the test, some values, and then the return code and pass or fail. And you can customize it so that you can expect a failure, stuff like that. Maybe I might end up making a video just on test suites, not in connection to this, but that might be something along the line or coming down the pipe. But again, we don't want them to look at this. We want them to say, hey, I want to open up Data Vault, so just type in Data Vault like so, not see that because that's an error, but if there was an application datavault.exe, and they would log in and say, hey, login, admin, test password, stuff like that. So we want them to be able to do that from the command line, and eventually that would possibly expand into an actual UI, but we will talk about that later on. For now, we're just going to be creating this in the terminal. So we're going to create two new files. We'll say terminal.h and terminal.c. And we'll just have the code open, nothing else. Get my code open on my reference. And there we go. Okay. So in terminal.h, we're going to do our macros. So if not defined, terminal h and if, define, it's been a while, and if. And we're going to have just a single function, void terminal. So this will just open up the terminal interface. And in terminal.c, what we're going to do is we're going to include terminal.h, like so. And then we are going to just have that function definition. So void terminal. And for now, it does nothing. I suppose we could say we will include standard IO. We'll also include string and standard lib for now. And we'll just say printf. Sorry, give me 2 seconds. There we go. We'll say printf hello terminal. And then in main.c, what we will do is we have this test mode variable that's new. So test mode will say, all right, let's run the tests, and otherwise we will run some other user interface. So we have the if it's a test mode, then run all the tests. Otherwise, we're going to say else here. We need to include terminal actually. So in main.c, make sure to include /source/view/terminal/terminal.h. Now, in an ideal world, when we run this application, we don't want to be including these two files in the same spot. This is the view, and it should be completely separate from the controller. Now, the only reason they're in the same file is because we have two different running modes, the test mode and then the terminal mode. With the terminal, we're going to be communicating with the backend, so we will need to include the controller, but in the main running file, we really shouldn't be including both of them at the same time. So in the else block here, we will just say terminal, and that's it. So I can go ahead and run this. And again, for now, it will be bad. What do you mean? Undefined reference. Oh, because I didn't add it to the manifest. That's right. So we have our new thing here. So we need directory manifest, and we need to add the source/view/terminal. It's already in there. I might just need to update my run files. So /update run files. Did that change anything? Run.bat. Oh yeah, okay. So the terminal source files were not included in the run directory or in the run command. So now that we actually have terminal.c in our run command, you see it at the bottom there, we will be able to do this. So we see hello world, which is from the main file, hello terminal from our terminal file, and then goodbye world there. So that is exactly what we want, except in between hello world and goodbye world, we want to actually put in our user interface where they can interact. So terminal is just the entry point for the terminal interface. Now in terminal.c, we're going to have a couple of includes so that we can interact with the backend. So we'll say include //data vaults.h, include controller slash dv controller.h, because we're going to need to call the methods. We're going to need to call create entry, we're going to have to call all the methods that we define in dv controller.h. Pretty much everything here. We'll need to create an account, log in, log out, all of this stuff here. So that's why we need this here. And then we will also want, do we need CMath? Oh yes, we do need CMath, because CMath defines our Boolean. So include //lib /cmathematics/cmathematics.h, and then we will also need string stream. So lib/gs/string stream.h. So ideally, these would be in the terminal and the backend would be in two completely separate repositories, and they would each have their own libraries. But since this isn't too big of an application, we're just going to have it in one, and this kind of creates the essence of, all right, because ideally we would have a library directory within our terminal directory, and that library directory would have cmathematics.h and stringstream.h, and that is it. And then somehow it would call controller/dv controller.h, and that's how it would work. But enough from that. Let's actually start writing some code. So in our terminal, we will need access to a dv application, so dv app, and then we also want to define the debug variable, because when we're developing, we will want to have the output print. So in dv controller, we define, forget where it is, unless it's in default.h, but we define an extern variable. Here we go, yeah, extern int dv debug. And if dv debug is 1, then whenever we're in the controller, we're going to print out the output of some of these methods, just so we can trace the progress. And we'll probably want to control that from the terminal with a command, just while we're in development, of course. So we'll say int dv debug is equal to 0. Now this will lead to some conflicts, because we also define that variable up here in main.c. So you can just delete that from main.c for now until we find a workaround, but dv debug is 0 to start. And now we're going to start our method, our application. So we will first initialize the application, so dv init reference to app, and then afterwards we're going to say dv kill reference to app at the end. And then what we're going to be doing is we're going to be taking in commands from the command line, and we will be getting the results, and based on the results we will quit or not. So we're going to have to store a command in a string stream, because we can add this and parse it very easily given the methods that we created. And then we will also have an int result value, which is equal to dv success by default. And this constant is also defined in default.h up here. So we're going to say while the result is equal to dv success. Actually, no, we should not do that, because sometimes you might look for something and it's not there, but we don't want to quit the application. So we're going to need a couple of extra codes, and I guess we can define them in dataVault.h, where we will say, actually no, these won't be in dataVault.h. We'll put them in terminal.h, because they will be specific to the terminal. So we'll define two values. So define dv quit as -1. We're going to go into the negatives because the controller takes all the positive values, and we can't assume anything. Again, we're not assuming anything about the controller. We're just accessing the methods as is. So we need to go into the negative values here. So -1 for quit, and then we will also have define dv invalid command as -2. So sometimes we're going to want to have a separate indicator for that. So in terminal.c, we'll say while the result is, while the result is not dv quit. Okay. And then in here, what we're going to do is we'll prompt the user. So we'll print out a greater than sign, just kind of an easy way to prompt them, hey, you can do this. And then we're going to start writing into our command. So we'll say cmd is equal to string stream allocate default. And then we'll say character, or sorry, so now we need to start reading from the command line. Now, reading from the command line in C is a bit of a tricky process. You could say get line, but I haven't found, I don't know why, I just haven't been able to find how to actually do that reliably. And if you try and do scanf, well, you're going to run into, scanf is not very flexible because you have to specify the exact format, but with us, we may have different numbers of command, a different number of arguments, because there are some commands that are like dv login, which takes in a username and a password, so 2 arguments. And you will also need dv create entry, which just takes in the name. Or you'll need dv create entry data, which takes in a name, a category, and a value, so 3 arguments. So scanf really isn't what we want to get here. I'm sorry, I just had the nicest swig of water. Just had to take another one. Sometimes water does just hit different right out of the fridge. Straight from the Brita. It's condensating at the perfect amount where it's still freezing cold, but it's not too hot out where it's just dripping down the glass. It's at that perfect point right now. So the most flexible method that we're going to use is get character, which will just read a single character from the command line, and then we will add that to the buffer. So character ch, and then while ch is equal to get char. This is from standard.io.h. And while this value does not equal new line. So whenever they hit the enter key, we want to process the command. Like so. And we'll say string stream concat. And it will be, we're concatenating it to a command. The format is just %c for a single character. And then ch. Like so. And then for now, I suppose we can just print out the command, because just to make sure that this all works. So we'll say cmd.str, we'll print that out, and then afterwards we will say string stream clear reference to command. So this printf is just a placeholder for where we process it. So we're going to say, we'll just actually comment it out here, or just comment here. Get command, process command, and then prepare for next command. So that's practically what we want to do at this point. And if we go ahead and run, hello world, hello terminal, I'm just going to enter in ASDF, and it just prints out ASDF. Now let's try login test pwd, just to make sure it's getting everything. And it gets all of the characters because it's reading until we actually hit the enter character. And I can do it again. Create account test pwd, and it does the same thing. And you know, we might also want to add something like CLS, which will just clear the screen, or log, which will print a couple of values out. But that is good there. Now let's try actually putting in a quit command, because I don't want to have to hit Command C every time. So in our process command, or to process the command, we will create a function to parse this out. So it'll be above, it'll be a local function, and it'll return an integer, and we'll say process command, and it'll take in a string stream pointer CMD. And then in here, we will say results, so the return code is equal to process command passing in a reference to CMD. And then we'll do a switch on the results so we can actually just output something else to the user or prepare for the next command. I'll actually put this here. So we process the command and then we prepare for the next one based on the result of the previous one. So if case dv invalid command, then we're going to print out invalid command \n, case dv success, printf success. I'm not sure what's up with the indentation here. There we go. I also need to do a break. And then case dv invalid inputs, we will print out invalid input. So this might be when we can't find something, or when there's just an invalid login, something like that. Break, and then otherwise we're going to print out the error code. So default and for now we're not really worried about making it pretty, so we're just going to print out the numerical error code, and we won't have a mapping between, all right, hey, this is a success, and we won't, I mean, we could also create an error message system, but again, that's just all to make it pretty. I just want to show you guys how to create an interface, and you can expand from there. So we have the results here, and then in the process command, this is just what we're waiting for now. So what we will say is, in command, we want to make sure that there is a command actually. So we say, if not command and command dot string and command dot size. So we want to make sure that the command pointer exists, it has a string value, and the size is greater than 0. And if if one of these things are false, then we're going to return dv invalid command. And then we're going to want to split this up and do our tokens. So we did a little bit of token parsing in, oh god, that was a while ago, with CMath, with expression parsing. And we did the reverse Polish notation, but here it's just going to be a lot simpler because we want to split it across characters. So it's just going to be like string.split. And there's actually a method for that that I guess I added afterwards into the string stream, but it'll return a character double pointer, so a 2D array, and integer n is equal to string stream split. We're passing in a command. The regex character to split across is just the space. We're going to output to a reference to tokens, and then we will take a maximum of 2 characters, because at this point we're going to be taking commands like login, and then there's an argument. So we essentially want to split the command from the parameters. So we just want to identify what the command is. So split command into, I'll say keyword and arguments. So the keyword is the first thing that comes, and that's what identifies. And then we will say, just for checking, if not n, if not, then in parentheses n and tokens. So if either of these are not true, then we're going to return an invalid command. And then we're going to take in we're going to return a return code, and that will be by default dv invalid command. And I suppose we could just put that up top, actually, this return code, and return that here. Okay. Now, what we are going to do is, I suppose, to follow suit with the controller, we will do a do while false loop, so we can just break out of it at any point. So do while false, and then afterwards we're gonna return the return code. And in here, what we will do is we will take the initial parsing, and we, instead of returning the return code, we will just break. Because we don't want to execute anything else. And we're just going to return that code either way, so we might as well just put everything in the do while loop. And now, let's just look at the quit command. So we have our tokens, and it's either going to be 1 or 2 tokens, because some commands like quit don't even take any arguments. So what we will say is, if not string compare, tokens at 0, string 2 will just be some quit command. And for now, we'll just put quit. We will define them as actual parameters up top, so we don't have to do it like this. But if it's not, if that it returns 0, then the two are equal. So what we're going to start with is we're going to log out of the app. So if app.loggedin, then dv logout reference to app, and then the return code is equal to dv quit. And let's try and run this. So we have hello world, hello terminal, and then I'm going to hit do commands, invalid command, good, doesn't recognize it. More invalid commands. Don't enter anything, invalid command. And let's say quit. Done. Error code -1 because it doesn't, it didn't get a recognized one, and then goodbye world, it exits, which is precisely what we want. So we can also have a confirmation. So let's say we want to make sure that the user can quit. And we will also delegate this to a function, because there is going to be possibly there will probably be a couple of instances where we would want to do this. So we will return a Boolean, get confirmation, and this just prints out a message. So the character result is equal to space for now, but while not result is equal to y, or result is equal to n. So we want to get a valid result, yes or no. And then we'll print out the string with a y/n to indicate what they should print out, or what they should enter. And then result is equal to get char. So this time we're just going to be getting a character from a single character, and we're going to be passing that into result. And if it's neither, then we want to reprompt them for it, because they need to enter something valid. And then we're going to return result is equal to y. So in process command, we will call this function now, and we will say if not get confirmation on are you sure you want to commit or quit. So if this returns false, then we will return, or sorry, ret code is equal to dv success and break. The reason why we're setting dv success is because if they don't want to quit, then we're just going to resume as normal, but nothing wrong happened. So we can just interpret it as a success. So let's test this out. We'll do /run. Hello world, hello terminal, invalid command, quit. Are you sure you want to quit? No. Returns invalid command. Now that is what we don't want, but let me just make sure that the yes works. Alright, so I hit Y and it printed out and it exited the app. Success invalid command. What happened? We go back into here. DV success. That happened there. Was it reading? Hold on. Oh, you know why? Oh, I know why. Because I hit N and that was read in this function by getChar, but then I hit enter and it didn't like that. So let's try running this again, and I will do ASDF invalid command, quit, no, but it's not moving, which is interesting, because it's reading a character right now, but I guess it's not getting sent to the command buffer. So if I hit enter, it will first read the N, and then it'll read the new line, and it'll say, hey, that's not an OK command, invalid command, but I suppose that's fine for now. And then, yeah, we'll do quit. Yes. Good. All right. Yeah. I guess, yeah, that's interesting. Okay, that's fine. Let's also just program a second command real quick. So else if not string compare tokens at 0, and we'll just say CLS. Then we will just print out or execute the system command CLS in the current terminal, and then ret code is equal to DV success. And let's try this out. So if you sometimes just want to do CLS, and it'll do that. So it'll clear the screen, then print out success, and then you can enter your new commands. So that will be very helpful. All right, I'm gonna get tired of writing all of this, so let's make a macro up top here, or above the function. So we'll say define str equals, and it'll just take in a pointer command, and this will return not string compare tokens at 0 and the command. So string equal is now a macro, and we just pass in the command that we're testing against, so quit and CLS, and it will return not string compare the two. So we can replace these commands here with string equal quit, and then for CLS, string equal CLS. And let's run this again just to make sure it works. CLS, all right, good. That's gonna be fun. Because now these statements, or these conditionals, just become much simpler to write. All right, so let's do some more fun stuff here. Let's do a switch that we can modify how the application functions. So we'll say else if string equal debug. So this will say if we're we want to essentially toggle debugging. So we will first just set dv_debug to not dv_debug, just to reverse the values. And then if dv_debug, then we're going to say printf turned on debugging. And then otherwise we're going to printf turned off debugging. And then we say return code is equal to dv success. So this will just allow us to switch between the values. So we can try this out. So I think debugging is set to 0 by default. So if I say debug, then it says turn on, debug, turn off, so on and so forth. Good stuff. Alright, so now let's actually, so we have some of the utility commands out of the way. Let's write some of the methods for actually interacting with the backend with the controllers. So we'll start with create account. So else if string equal, and we'll just say create account. And in here we will say we will need to take in the parameters. So create account, it'll be create ACT, and then we will also need to pass in a username and a password. Hence we're going to need 2 tokens. So we have the keyword, and then we're going to need arguments. So we need to say if n is less than 2, then return code is equal to dv invalid command, and then break. You know what, I suppose we can organize this actually up here. We'll say commands with no arguments, so that's these here, and then we'll do another one, commands with 1 argument. So we can just factor out this if statement to above everything, and it will run for trying to parse all of these commands that take in 2 arguments, or that take in 1 argument. So, and then we'll create account, well, that actually takes in 2 arguments, so commands with 2 arguments. So if n is less than 3, then return code is equal to dv invalid commands, then break. So create account, we know we have our token. Sorry, create account, right now it doesn't take any username. That's my mistake. This actually does just take in 1 argument for now. Sorry, yeah. So create account, we will say printf, we'll just print out create account with password. Just print out a couple of things here, and then we will print out the string length. Now the password is stored in the second token. Since there's only 1 argument, we just need to take that token as is. So tokens at 1, and then we will just print out tokens at 1. And then we will actually call the controller method. So we're going to say dv create account, and we'll pass in a reference to app, and the password will be tokens at 1, and then the string length will just be string length of tokens at 1. Now again, we want to return the status of what happened here, so we're going to say ret code is equal to that. So we're creating an account with the password, and then we return the return code to the terminal function here. So let's go ahead and run this. So we will say /run. I'm going to clear our screen. And we'll say debug. So we'll turn on debugging. And we'll say create account with the password test pwd. All right, so this is printed out from our terminal file, and then this is all the output from our controller. But it's returning invalid command for some reason, which I don't like. Encrypted data key. It seems like it's doing this properly. I don't know why. Oh, because then return code is going here. So, I see. You know, we can actually just, we can kind of, let's try this. So, commands with no arguments, we have the if. So, only one of these will run, if any. There's no else there. We can make this if n is less than 2 to an else if, and if this is not true, then none of the rest of these commands will not execute, so we don't need to put a break statement in there. So if we just do a long string of if and else if statements, even if we are separating them, we don't have to put a single break statement because only one block will execute. So what was happening was it was getting the return code from create account, but then it was running into this if block, if n is less than 3, but because we only had 2 arguments, then it wasn't really working. Actually, this isn't going to work anyways. So I'm going to comment this out for now, but let's just make sure that the create account function works. What? Why can't I quit? Oh, because yeah, it's running back. So run create account test password, and there we go, success. And let's try it with debugging. Create account test pwd, and success. Good and good. So that's create an account. Now, the problem that we are running into is, well, n will never be 3. We're only parsing this into a maximum of 2 tokens, as defined up here with string stream split. So what we have to do is we're going to parse our second token, if it exists, into further tokens. So we'll split that up. So what we're going to do is we will do another split command. And I actually never really I never really freed the split command here. So we need to say character double pointer arg tokens is equal to null, and then we'll say string stream arg stream is equal to string stream from string. So we're going to take the second token and we will just put it into another string stream, so tokens at 1, and then we're going to get the arguments. So int arg n is equal to string stream split reference to arg stream, again splitting across spaces, and then the output is a reference to arg tokens, and we will split into a max of, I think 3 is the maximum, because there's create entry data, which takes in a name, a category, and a value, so that should be 3. So we should actually hold the phone here. int arg n is equal to 0, and if n is greater than 1, then we do have arguments to parse. And then after this, we want to say string stream clear arg stream. And then also at the end of each iteration, we need to free tokens and arg tokens. So at the end here, we need to say if, let's see, if tokens, then string stream free, I forget what it, I could swear I created a function for this. Did I not? Free string list, that's what it was. Why did I? That isn't string stream, okay. So there's a new function called free string list, and this just passes in tokens, and the number of tokens is just n. And actually, this will always be true, so we'll say always do that, and if arg tokens, then free string list arg tokens and arg n. So we always know that there are tokens, because otherwise we would have broken out of the loop. But then we're going to free the argument tokens conditionally. Okay, so now what we can do is if arg n is less than 1, then we cannot execute any of these commands here. We cannot. And then we will also do the same thing for 2 arguments. So if arg n is less than 2, then we cannot execute any commands that require 2 arguments. I forget which ones there are that do have 2. I'm not sure if there actually are any, but yeah, not sure. Get and, oh yeah, get and delete will require a name and a category. So those will require 2 arguments. So we have create account, which takes in one argument. We will also have login take 1 argument. So else if string equal login, then printf logging in with password, and this will just be the exact same as the create account with a couple of different things. And this time we're going to be calling dv login. And then we will also create the logout function, the exact opposite. And that will be done with no arguments. That will be put up top. So else if string equal log out, then we are going to say, forget what I wrote for logout. It's just printf logging out, and then return code is equal to dv logout. All right, so let's try and go through just a random flow here. We'll just create an account, log in, and log out. So /run cls to clear our screen. So we'll say create account test password. Uh-oh. Didn't like it at all. Let me try debugging. So turn on debugging, create account test pwd. Invalid command. Why did it not like that? Create account test password. Invalid command. Why? I don't like this at all. I'm just going to try and print out the output of this string equals function. Oops. And you know what? Let's just, for good measure, and let's at the start, let's, at the start of terminal, we will say, system CLS, just so we can actually see what we're looking at instead of looking at all that build output. So create account test pwd. Create account, yes. Okay. So it's recognizing it. If I put on debug, what is going on? No, I can't have the backend. Damn it. It was working. This is such a shame. Create account test password. So it's recognizing it and it's calling the function. It just doesn't like what it's looking at, which is such a shame. Okay. Do we dare debug this? I mean, I suppose it is possible. You can use GDB to debug this still. So we'll say whenever we go to terminal.c at line 111, we want to trigger a debug or a breakpoint. Terminal.c111 run. Create account test password. Oh, so this, okay, good. I am glad. This is not something that has to do with the actual data fault. Good. And you know what? I'm actually stupid. Yeah, it isn't, because create account with password wasn't printing. Okay. So it definitely has to do something with parsing the arguments. Okay. So argument tokens is null, and this should be if n is greater than 2, because otherwise we're not going to need to split anything from tokens at 1. So in create account, we should just be taking tokens at 1. And this doesn't even access the argument tokens. Oh, yeah. This is... okay, let's try this out. All right, create account test pwd. Invalid command. What? Now I don't like this. Debug. Turned on debug. Create account test password. Invalid command. No. What is going on? Oh, if argument n. Oh. Okay, so I'm screwing up now. So when we parse our arguments, we're only going to split the second token if we have more than one command, or more than one argument, because otherwise the argument is just stored in tokens at 1. Don't need to split anything. Now, in here, we're saying if argument n is less than 1, well, we don't assign to argument n if there is one argument. So if n is less than 2, we we need to, if n is less than 2, then we break. Otherwise, we're fine. Otherwise, we do this. Okay, now let's do it. Create account, test password. Good, thank you. Okay, so create account with password. Success. Let's try logging in with test password. Logging in, success. And then log out, success. Log in again, success. Create account, test pwd2. Let's try logging in with test pwd, the initial one, invalid input. Let's clear our screen. Log in, test pwd2. Good. Log out, quit. Good flow. So we have that all polished. Now let's do some of the more complex operations. So we have our account management. Now we need to be able to manipulate our data. So we have a couple of functions for data manipulation. There is create, set, get, and delete. So create entry will create the entry, no data with it. Set will just call set entry. Now, set was one of those functions that I didn't write on stream. But all you need to know is not datavault.h. I want to go to dvcontroller.h. Datavault set entry data was simply just deleting the entry data and then creating it again. And if it didn't delete it, we didn't care because we just created it. That was just the easiest way I thought about it. It was simplest, probably not the most efficient way, but it worked out. Okay, so we have that function there. And let's try and interact with them. So we have 2 arguments. Well, actually, the first command that we will look at is just create entry. And that has 1 argument. So else if string equal create. And we will say printf create entry with name. And I guess it's going to be the exact same here. Or it's going to be kind of the exact same process as dv login. Because we have a single token and we want to print out the token and its length. Except return code is now going to be dv create entry with a referenced app and tokens at 1. So if we can look at this, let's test this out. So /run create account test pwd login test pwd, and then we'll say create Lego. Success. Now if we go take a look at our output files in the test here, can minimize that and run. We have data.dv, and I will open this with hex editor, and we have 2 blocks here. One for just the initial salt, and then we also have our first block that we created. Let's try doing another one and see how it works. Create, what's another good company? Wow, there's so few of them. You know, let's put some let's put some sensitive data in here. Create SSN, your social security number. We see now. Let me reopen Data Vault or the file. 3 blocks now. So it is working. All right, and then we will go log out and quit. Now let's just make sure that this is in fact working. And I created another function in Data Vault to actually log some values. So this will log like your entry IDs, your start indices. So this is going to take in no arguments. So it'll be else if string equal log. Then we will just call dv log with a reference to app, and then return code is equal to dv success. Like so. So we just call the log function, and since there's nothing to process, we're just going to return success. That's what we want to do by default. And you know what? We're setting return code to dv success a lot. So why don't we make the default return code invalid, or yes. All right. So before we enter the if statements, let's set ret code is equal to dv success. This is by default. So defaults to success. Once we actually know that the command can be parsed, then we will do this. And then after get confirmation, then we break. Wait, sorry, if not get confirmation. Yes, so if not get confirmation, then we don't want to quit. So we just break and we return success. Otherwise we set that. After CLS, we don't need to set the return code. After toggling debugging, don't need to set the return code. And then after log, we don't need to set the return code. And again, this will never get executed because only one block of this conditional will get executed because they're all else if statements. Sorry, there was a fly going around. So CLS /run. Let's just make sure this works. Create account. We'll turn on debugging. So success, good. So the default is working. Quit, yes, good. Quit, no. Okay, good. CLS, login test password. And then I'm going to do log, and what this will do. So logged in is true. And then we have name, ID, and start index. So Lego is at ID 1 and start index 1. Social security number is ID 2 and start index 2. No categories yet. Precisely what we want. Let me go get some water. My throat is burning up. I'm back. All right, so we have that log function. This is just something else that we can do here. And then I will quit. Let's also do a print function, which will actually just print out the data file decrypted. So else if string equal print dv print data file referenced app /run login test password, and when I print, that is good. So what it does is there are 3 blocks to read. It skips the first one. These are the blocks encrypted on the left here, and then these are the blocks decrypted on the right. And again, we have the placeholder 0x22 value with the 0 continuation block. So this is perfect. Exactly what we want. So I'll quit, and quit will automatically log out as well. Now, let's do some data manipulation. So we have create entry. Let's do entry data now. So set. So that will, in fact, take 3 arguments. So commands with 3 arguments. So else if arg n is less than 3. So return code is equal to dv and valid command. And if this is false, then we move on to the next conditional to look at. So set here will say else if string equals set. Then what we will do is we will set print out setting data for a name under a category. So the name will be args at 0, or sorry, is that args or arg tokens? Arg tokens at 0, arg tokens at 1, and arg tokens at 2. And then we'll say print return code is equal to dv set entry data referenced app args at 0, args at 1, args at 2. Sorry, this should be arg tokens at 0, 1, and 2. So we have the set, and let's try getting this data. Again, this is not going to be this video has not been very intensive. It's just understanding how user interfaces can be programmed. So we'll do get now. So this is a command with 2 arguments. So we say else if string equals get. Then we say printf accessing data for %s under %s. So arg tokens at 0, arg tokens at 1. Then we actually need to allocate a value, a variable, to take the output. So character pointer out is equal to null. Then return code is equal to dv access entry data referenced app args at 0, arg tokens at 0, arg tokens at 1, and then the buffer will be a referenced out. And then we print f retrieved %s, and we just print out the output, and then free out. So all we're doing is we're just printing a status indicator, allocating a variable to read to, then we call the controller method, passing in the application, the name, and the category, and then the buffer to output to, and then we print out the output and free it. So we should be able to look at this now and actually look at and manipulate some data. So let's open up our terminal, run. All good there. We will say login test password. Good. We'll log, so we have a social security number, a Lego entry. Let's let's add our social security number. So set name is SSN. We'll say the category is just value, because social security number. I mean, I guess you could put your name in there, but what do we want to put? Does anyone have a social security number that they're willing to give? Does anyone actually? Should I ask you guys for your socials? If you don't, I understand. But I'm gonna put my own, of course. So my social security number is 9 digits. And it's 784-243-561. That's my social. No, I'm not shitting you. Enter. Invalid command. Great. Okay, so it's actually just not, it's not getting this. All right, so I don't think it's parsing well. Oh, because it's never going to parse the argument. That's stupid. That's really stupid. If n is greater than 1, we have to do this. So this parsing was not working before. So I'm going to debug actually. So quit /debug. Break terminal.c 52. Right? Yeah. Run. Login test pwd. All right, so we're breaking here. So next, print argstream.string. So it's test password, that's the argument. Now this is where I think it was screwing up. So this might be a problem with the split method itself. But let me just try going next. Print arg n 1. Okay, that's actually... Alright, didn't like something. So it's on the string stream clear. Now that is interesting. That is very interesting. Let me look at what split actually does. So we have a double pointer for the return. Return is that blah 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 blah. Cursor. Hold on, I'm not gonna understand any of this code. So we say if the rejects, then if string length, good, add to the string, add string to the list. It doesn't like that. All right, string stream clear. It's not like it. I don't think it's gonna like this actually. Split better not free the value. All right, let's go through another debugging. This is, I'm looking at, oh no. I want to break at 53. Run. Login test password. Next, print argstream. The string is fine. Capacity is that. Size is that. Okay. Let me step into it. Is this not what? Print s.str test password. Is this? Why is it? Oh, because is it a const character pointer? Is that why? Yeah. Okay. All right. So let's break this down a little bit. Right now, tokens at 1 actually should not be a const character pointer. However, I'm just not going to screw with this. Argstream, do not free it. It doesn't matter. If you're getting errors, do not free it. Also, I reassigned argument n, so that value won't have anything in it. Was that the problem? That better not have been the problem. Okay, see, now that was... Let us not do that. Let us just not free the argument stream. Let's actually, you know what? Here we go. Let's allocate the string stream up top. Arg stream. And then at the end we will say free the argument string stream. If arg Okay, now hopefully that works. cls./run login. Okay, so we're logged in. Let's log this now. So we have that, and then let me hold on. Never mind. So we're gonna set the social security number again. It's value. I just said it. If I forget my social. Does anyone have a social they want to give? All right. You lost your chance. You can't have your social displayed on a live stream. That's your fault. 621-854-724. Enter. Success. Log. So now we see we have our Lego and social security number entries. Now their name is that, the categories, and we have a value as a category. Now if I go clear the screen and print, we see that I have some data in the entry there for the social security number. So let's say get SSN value, and we get the value that we just entered. So if that's your social security number, I am sorry for exposing you, but you should have volunteered it, or you should have volunteered something different if you knew that was yours. But so get and set now works. All right. So we have set, which takes in 3 arguments. Get takes in 2, and then our final command, delete, takes in 2. So at the end of this block, we will say else if string equal del. Then we will say printf deleting data for %s under %s, arg tokens at 0, arg tokens at 1. And we say return code is equal to dv delete entry data, pass in a reference to app, arg tokens at 0, arg tokens at 1. And then we don't need to do anything else. All right, so we'll run. Login test password, log, so we still have everything. Get SSN value, still works. Del SSN value, good. Print. How do you type? Homie, you're typing right now. Why? Is this an average viewer? Are these what my this is so I thought you guys were all Giga Chats, and I have some dumbass asking me how do you type when this dude is typing in the chat. You know what? I'm here. Let me bargain with you. Type in your social security number right now, and I will show you how to type it out. All right. And while I wait for him, let me explain what happened here. So we have delete SSN value, and it deletes it, so there's no more data left, which is good, which is exactly what we want. I'm not gonna explain how many hours I spent debugging this, but it works now, which is the only thing that matters. Let me say set SSN, or not SSN, Lego username. Lego 4123, that's my username. Get Lego username. Print. It's over there. And you'll see that username has an ID of 2, which is what we want here. That's what we have here. And let's let's see what, let's add some more data. So set Lego password, get Lego password. Good, print it out. And we will see now that we have our data. Oh, sorry, we have the initial data here. So this is the username, then the 00 for terminator, and the 03 for the next category. And then we have our first couple of bytes, and then we have the continuation block as 3, goes over to here, 00, and then 2, 2, 2, all the way over. You know what? If you guys are struggling with watching the first part of the videos where I was kind of explaining how I wanted to do this, watch these videos because this diagrams it out so much neater. So essentially, this is one block. The first 14 bytes are the data. The last 2 bytes are the continuation block in small endian values. But then we have an empty block here. And then let's, for the sake of just proofing this, let's say del Lego username, print, and now it works perfectly. All right, so I am very excited now that this is in fact working. Let's take a second to ponder here. So we have currently so this is our user interface right now, just the one. We can't do too much with it, or that's wrong. We can do a lot with this. However, might be nice if we just want to run one argument and not have this application just running in the background the entire time. So let me actually blow my nose so I stop sniffling into the microphone. Sorry, I'm gonna mute myself while doing this. All good. So there may be times when we just want to execute one command at a time, or we may just want to have this application not running in the background, so the user just doesn't stay logged in, because that is a serious security that is a serious security vulnerability. If this application is running and the user has logged in, if some malicious outside hacker is able to gain access to this user's computer, and they are in fact logged in, they're kind of screwed, because the hacker doesn't even need access to the password. They can just type in a command and they'll get the data. So we want to create a way to just execute a single command. You pass in your password, and you pass in the password, and then all you're going to do is you're going to pass in the command after the password. So let's diagram how this would look. So let's go into main.c, because main.c is our entry point, and this is where it's going to happen. We get our arguments from main, so it'll be int argc and char double pointer argv. I think that's it, right? Or is it char double? I forget what the order is. C main function. Okay, so it's argc and then argv. Okay. So it's that. So argv has argc number of arguments in it. So what we are going to do is we want to figure out a way to say, hey, if argc is more than 1, so I will actually be creating a new run file here. So this should actually not, we don't want to execute this anymore. We don't want to make the executable. So we can actually do something here. Let's go into generation, generate run file.py. And I want to say this. So we're going to write the build command. So with open f build.bat. So if you don't know what's going on, don't worry about it. This is just some stuff I wrote before to have an easy way to just update my run files. So that's good. And then cd the run directory. Okay. So when we build, we will put you in the build directory and on the command line. So if I run now /update run files, I now have a new batch file, build.bat. And it just generates our output file and it just puts us in that directory. So as an example, CLS, if I say /build, builds it, and then we are put in test. Oh, it's not. That might not work on PowerShell. So cd run dir, we have, and then we can just execute /main and do our commands here. So that's fine. That's okay. But we now have char pointer argv. We now have command line arguments here that we can also implement or use. And the way we'll determine if we want to have a command that takes precedence over just opening a terminal session, we will say else if argc is greater than 1. So the initial value main, so the executable /main, that counts as one argument. So we need to see if there are additional ones. And we're going to create a new function in terminal. So we will just say void single command, and we will pass in a const character pointer, sorry, this should be a character pointer password. And then we will also pass in any other arguments here. And I need to refresh myself on how that works. This is code that I am completely winging. However, I know I have an example of this. What do I have it with? Is it? Give me 2 seconds to think about this. I'm just going to look this up. C-var. Oh, it was with C mathematics, the vectors. Either way, I'm just going to look up a simple example. It was with the vectors. That is what happened. Okay. So new vector, and we're going to have a single command with the number of arguments, a password, and ... So this will just be the number of arguments there. Actually, how do I want to do this? We will say char pointer argv double pointer. Okay. So yeah, we have a password, which we will always need. That is required. And then argc, which is just the number of arguments that come after it, and then argv. So we have main here. And we say else if argc is greater than 1, then we have stuff that we need to parse. So we will take in the password. Character pointer password is equal to argv at 1. So that's just the password. And argc should actually be that, or so it just has to be greater than 1. So now what we want to do is single command. We pass in a password. Password argc will be argc minus 1. And then char double pointer argv. Now, how do we advance this one pointer? Argv plus 1. Let me try this out. So printf %d %d %d. So argc, argv, and argv plus 1. So I just want to see how the pointer computation works, because I want to see if this needs to be a +1 or a +4, because this is just saying, hey, we have arguments that we want to give you, but we don't want you to read the first one, because the first one is just being delegated as the password. That will always happen. And I don't want to, or I mean, I guess we could just leave the computation of that to a single command. Yeah, that's fine. We can just do that. So we'll pass an argc and argv to single command. You know, yeah, we will avoid the heartache. So single command. It's going to look kind of the same as terminal. So I'm actually just going to copy I'm going to copy this stuff. So we have printf, and I'm just going to copy all of it actually, and we will delete what we don't need. So we're still going to process the command, except this time the command, we are just going to take, we need to first take the password as a value. So we say integer I is equal to 0, so this is our index into the array. So character pointer password is equal to argv at I, and then I++. So this can actually just be combined into one line. So our password is here. We should actually be making sure that we're passing in main here. We need to pass in a password and an argument. So a password and some sort of command. So there needs to be more than 2 arguments in the run command. So we get the password, and what we will do is we will now execute this command as a, and we will tell the compiler, hey, I want you to execute this command, and that this will be hard coded in. So we'll say command is equal to string stream from string log in with a space. So we're going to log in and we're going to set the password there. And then string stream concat reference this command. The format, we're just going to be concatenating the password. Just like so. So we're going to be constructing the login command. And then we will also be saying cmd is equal to string stream from string log out. So we have our here. So what we're going to do is we're going to process the command so we're going to get the result and process the command. So we have our login command here, which is login with the password, and then we're going to process this command, get the result, and the only possible result that we want to break on is when it's not a success. So if res, we can actually just say if res because dv success is 0. So if result, then we're going to again, we will also do this in a do while loop, do while false loop. I will call string stream clear on a reference to command at the end. So printf could not log in. Break. Now, let's try this. So printf logged in, and then we also want to process the log out command. So we have logged in, and I guess we need to free the actual command before creating another one. So this will be string stream clear reference to str, or reference to command. And then we will delete everything in the loop here. So let's just go over what we have again. So in single command, we take in the command line arguments. We actually need to set I to 1 because, again, the first command will be main. So the password is the first argument. So we have printf, hello terminal, clear the screen, initialize the app. We have our variables here, have our index as 1, and character password is I++. Or sorry, the password will be that argument there. So then we take that password and we concatenate it so that it becomes login with the password, and then we process this command. So we are programmatically constructing an argument or a command to be run. And this is kind of what I was talking about, of how you can create a physical separation between a view and a controller. Because on the user interface side, we only have the terminal interface where we're just writing a command. But is this really any different from, we have our program, we can say it's main.exe. Can we not call main.exe from an actual user interface like a website or a GUI application, that when it takes input from a user in text boxes or whatnot, it will construct a command with main.exe and pass in the arguments? It will be able to do that, and we can call this from outside of the actual program, is what I'm trying to say. But let's try this out. So we have our login command, print logged in, and then we log out, and that's all we do. So cls /build dir. So we have main.exe, so cls. I forget, was our password test pwd, right? Main test pwd /main. Hold on, let's go into main and say because we need to pass in a command here. So we're writing our password, but it's not seeing any command that it could execute. So we need to say /main test pwd hello, or log, say. All right, so logging in with password, logged in, and then logging out. Precisely what we want. Good. So we'll say logged in \n for a new line. And then we will now we're going to construct the actual construct the command to execute. Construct data command. Something like that. So we have our arguments, and we already have an index in them. So I is now going to be 2. I can actually do this and just say int I is equal to 2, less computation, less instructions. Put that over here. I can actually just say that. And again, fewer computations. So what we essentially want to do is just take in our data commands and just put them in a string stream. So we're going to say string stream clear references CMD. And we'll say CMD is equal to string stream from string. And we'll start with argv at I, or we'll say at 2, and then we will start our counter. So for int I is equal to 3 now, I is less than argc I++. Okay. Oh, that's incorrect. So what are we doing here? So we have, so the parameters go like this. We have argv at 0 is main, so that's /main. Argv at 1 is our password. Argv at 2 will be the keyword, and then argv at 3 onwards will be the arguments, the parameters to our command. So we're just going to concatenate all of them here. So string stream concat, and the format will be a space, then %s, and then sorry, this should be a reference to CMD, space then %s, and then it's going to be argv at I, like so. Now we will say printf executing command %s, and we will just say cmd.str, and then we will process the command as we did over here. I don't know if you guys can hear that, but there's like I don't know if it's a cricket or something, but it's making a weird ass noise. So we will get the result, and then we will print out this here. So let me actually zoom out for you guys a little bit. So we have construct the login command that does this. Takes the login password, puts it in a command. Then we just print out logged in. Then to construct the data command, we start with the keyword. And if we have any runtime arguments, we concatenate them to the string stream. And then we're going to execute this command, process it, get the result, and then with the same switch that we had above, we're going to print out what happened in the command, and then we log out. Let's go and do this. So cd ... build. You know, I don't really like doing this. Sorry, hold on. Let me go to cd ... // source data vault run cd test. There we go. So we build our application there. Good. And then in data vault.main, or sorry, in data vault, the run directory, we're going to say /main, our password, so test pwd, and then we'll say our first command is print. All right, so good. Here we go. Logging in with password, test password, logged in. Executing command, print, open data.dv, 3 blocks to read, and we have our stuff here. So let's do, and then we have success, logging out, and goodbye. Now let's do /main test password, set SSN, or we'll just do a log to see what happens. All right, so SSN is still 2, so we'll say set SSN value. Any takers on the social security numbers? All right, that's fine. 451284561. Good. And let's try and get this. Good. Retrieved 451284561. So we now have a terminal interface that we can either open up a whole session, or we can just run a single command at a time, have to re-log in every time so that the session is never idle and logged in at the same time. I just think this is a much more secure way of doing it. But that is it for now. I'm going to try and find a way to do the where you can enter the password in the terminal but not have it actually show up, because I want to be able to just have the command be executed, or you pass and say /main print, and then it'll run print, but you need to, if you hit enter, it'll prompt you for a password over here before actually running the command, and I want to try and do that. But that'll probably be a shorter video that I record on its own. But alas, time is up. Thank you guys for watching. I appreciate it. We're wrapping up the data vault, the main part of the data vault series. As for continuing it, might get integrated into WebAssembly, and again, this will be rather simple to integrate it with WebAssembly if we have this terminal interface that can run one command at a time. Because we don't actually need to import the entire application into WebAssembly. We can have, again, if you don't know what WebAssembly is, or if you haven't been following the series, don't worry about this, but we don't have to port the whole application into WebAssembly. We can have the Data Vault instance running on your computer, locally on your computer, and then WebAssembly can interface with that somehow. You can figure that out. I will figure that out. Try to, at least. But I think that'll be a fun project. Either way, whether that happens or not, I want to thank you guys again for watching. I will be putting a couple more videos out hopefully soon on WebAssembly and whatnot. But yeah, hope you guys enjoyed. Hope you learned something. And I will see you guys next time. Have a good one.